Hi student, welcome to chemistry class with Emerald. This video is brought to you by Igotha Virtual Learning. And in this class today, we are going to be looking at the halogens or the group 7 elements of the periodic table. And in this video today, we are going to be looking at their description, their properties, their reactions, and all other that you need to know. Let's look at first the halogens. What are group 7 elements? Group 7 elements are called the halogens, and the word is gotten from two Greek words, halo and gene. Halo means salt, gene means forming. So, in a nutshell, halogens mean salt formers. They got this name because when they react with very electropositive metals like metals of group 1, they form salt easily. In group 7, members of this group are fluorine, chlorine, bromine, iodine, and astatine. Iodine is fluorine and chlorine are gases. Bromine is liquid. Iodine is solid. Astatine is radioactive. Let's look at some of their physical properties. These elements are non-metals. At normal room temperature, they exist as diatomic molecules. They have 7 valence electron in their outermost shell. They have 7 valence electron, and that's why they are in group 7. 7 valence electron in their outermost shell. Furthermore, let's look at their electronic configuration or electronic arrangement. You observe that, of course, that you can easily count the number of electrons in the outermost shell with this information, or you can even read their electronic configuration. Fluorine, for instance, is 2 7. You can see from the 2 7. What you do is count from the middle, or from the inner side. You have 2 at the inner shell. Then of course at the outer shell you have 7, 2 7. That means that if you add 2 and 7 together, the atomic number will be 9. The atomic number will be 9. The same thing with chlorine. Chlorine is 287. Chlorine is 287. That it will be 17, and so on. You can do the electronic configuration, of course, get the atomic number of the two others from there. Now let's look at their color. Fluorine is a pale yellow gas. Fluorine is pale yellow. Chlorine is a greenish yellow, or we call it green yellow gas. Bromine is brown or orange brown, or sometimes we call it reddish brown liquid, while iodine is gray black solid. Like we have said, astatine is radioactive. Now let's look at we are still looking at the physical properties of the group 7 elements. From this graph here, you observe that the atomic radius is increasing as you are moving down the group. From fluorine down to iodine, you notice that the atomic radius keeps increasing. It's quite easy. As you move down the groups, the number of shell increases. That means the outer electrons are going further away from the inner nucleus. Okay, so that makes the atomic radius, the distance between the electrons and the nucleus, to increase. The number of shell is increasing. Of course, the atomic number is also increasing. So the atomic radius increases down the group. Another reason, of course, like we have said, the number of layers of electrons around the nucleus is increasing. Like we have said, the number of shell is increasing. So and the more the number of shell, the bigger the atomic radius. So this is the reasons why the atomic radius is increasing. Then let's look at the interestingly the melting and the boiling points of the halogen. Uh, you observe that the melting and boiling point is also increasing uh, down the group. It's also increasing down the group. Um, a key information to know here is that the boiling point will also tell us the how volatile a substance is. The boiling point of a substance will tell us how volatile, how it is able to quickly escape or evaporate. So since we have observed that since it's increasing, that means the volatility of the halogens also increase down the group. Why do we have this? Um, Generally, halogens have uh, simple molecular structure, or they are simple covalently bond, and of course the bond between the atoms of each molecules of halogens have a weak van der Waals force between them. However, as you move down the group, the strength of this simple molecular structure and the van der Waals force keeps increasing, with increasing atomic number. So the greater the number of electrons that are available, the greater the opportunities for dipoles arising within the molecule. So the larger the molecule, the stronger the van der Waals forces, and of course the simple molecular structure become more stronger. So that is why we have increase in melting and the boiling points of the halogens as you move down the group. Of course, you also observe that again that in a simple term, you observe that like we have said, we are moving from gas to liquid to solid. Of course, we know solids are held together by a strong cohesive force, and of course, we require much more energy to break the molecules of solid. So, as you are moving from gas to liquid to solid, the melting and boiling point will generally increases down the group. Okay, so the halogens, let's look at the reactions of halogens quickly. Some of the reactions of halogen. Um, for instance, halogen require just one more electron to achieve a completely outer shell. Of course, to make an octet structure, like I said, for an electron or for an atom to be stable, it either have a zero, a duplet, or an octet structure. So in this case, to make octet, they require one electron. So therefore, they are going to have -1 charge because they will be accepting one electron um, to become that. And as such, because they will be accepting electron, especially from metallic elements, they react easily with group 1, group 2 elements, especially group 1. And of course, when they react with group 1 elements and group 2, they form ionic compounds. They are going to form ionic compounds. Of course, they will require a -1 charge. They gain electrons easily. Another one is, for instance, an example you see there is chlorine reacts with calcium. Chlorine can also react with sodium to form a sodium chloride. They are going to be ionic compounds. They react with metallic elements, especially group 1 and group 2. Please take note, to form ionic compounds. Another of their reaction is that they are very good oxidizing agents. And the reason for being a very good oxidizing agent is because they tend to gain electrons easily. So as they are gaining electrons easily, they get reduced. And of course, when they are reduced, oxidizing agent gets reduced, while reducing agent gets oxidized. So because of ability to gain electrons easily, they are extremely good oxidizing agents. So they move from 0 to -1 in their oxidation states. Now let's look at another property, another reaction, their electronegativity. And now you observe that the electronegativity will decrease down the group. The electronegativity decrease down the group. In fact, fluorine is the most electronegative element known. So electronegativity decreases down the group. That means ability to accept electron decreases. And what is the reason for this? The electrons are not as near to the nucleus as the number of electron decreases. So, like we have said, as you move down the group, number of shell increases, atomic number increases, and of course, because the atomic number is increasing, the number of electrons increases. So, as you move, the electrons get farther away from the nucleus. So the nuclear attraction here will decrease rather. The nuclear attraction will decrease, and of course there is an increase in shielding. There is the shielding effect. Increase in shielding is observed. So the ability of electron will now decrease, which means that the electronegativity will decrease down the group. The electronegativity will decrease down the group. So again, let's quickly look at let's look at um, the oxidation state of, that's another property. Let's look at the oxidation state of halogens. Halogens could range from -1 to +7. Why is this? They can to make octet, they can either lose one electron, gain one electron. For instance, fluorine is 2,7. When it gains one electron, it becomes 2,8 to form a octet. Either they gain one electron or they lose the 7. By losing electron, they become positive. For instance, in chlorine or fluorine can lose 7 electrons to become 2, which is a duplet. Will still be stable. Like I've told you, we have said that to be stable, you have to have either 0, duplet, or octet configuration. So when chlorine loses 7, it can become to a duplet. When fluorine loses, it can become 2. When fluorine loses 7, it can become 2,8, which is octet. So they can either accept one electron to become octet or lose the 7, and that is why they're having -1 to +7 in their oxidation state. And this is elements of compounds that you have when they are in this oxidation state. For instance, in +7 state, you could have tetraoxo chlorate 7 compound there, and so on and so forth. So you can look at at 0 level, you have them in their gaseous form, F2Cl2, etc. So do well. You can do the calculate the oxidation state. You will find out that in this state, these are the compounds that we have for the halogens. Okay, so quickly let's look at some other key properties of the halogen family. For instance, fluorine. This is the electronic configuration we were talking about. You can study the electronic configuration here. Fluorine is highly toxic, colorless gas, and of course is the most reactive element there. Chlorine is also highly toxic gas, a pale yellow-green color, and is a very good oxidizing agent. Fluorine is the most important element of the halogen family. Bromine is reddish brown. It has unpleasant choking odor. Iodine is intensely colored solid with metallic luster. It is volatile. It sublimes when heated. Iodine is one of the substances that sublime easily. From solid, it moves to gas. And then astatine is solid radioactive element. Okay, let's look at some of the other properties of the periodic table in terms of the quantitative or numerical value now. Fluorine has, this is the atomic number, 9, 17, 35, and 53. You can see the number of stable isotopes that they have. Fluorine has 1, chlorine has 2, isotopes. Uh, that's chlorine 1735 and chlorine 1737. Bromine also has two, iodine has one. The other isotope of iodine is usually radioactive and is used in curing goiter um, or cancer. And then later on, we have the atomic mass, we have the electronic configuration. But more interestingly, we have the ionization energy. You observe that as you move down the group, ionization energy of the group 7 will decrease. The ionization energy it will decrease. And what is ionization energy? Like we have said, energy required to remove an electron. Why? Because the electronegativity, that's ability to gain electron, is decreasing, so the ionization energy will also decrease. The same with electron affinity. Electron affinity is ability to gain electron. Since the electronegativity is decreasing, the ability uh, to to accept electron, um, to add electron, rather electron affinity is adding addition of electron. Ability to add electron will also decrease because electronegativity is decreasing. We have talked about melting and boiling point the other time, and then of course the ionic radius is relatively increasing here, while the electronegativity is decreasing. These are the numerical value that you can use to pinpoint them. Okay, so let's look at their further reactions again. They Since they are non-metals, they can form covalent bonds. Like for with metals, they will form ionic compounds, but with non-metals, they will form covalent compounds. They can react with hydrogen to form HCl is what's it called? Is covalent, and then they can also react with especially group 3 metals to form a covalent compounds as well. They react with aluminium, for instance, to form a covalent compound. um, uh, as you go down the group, the halogens get less reactive as you go down the group. So that since the electronegativity is increasing, so they get less reactive as you go down the group. Now, another interesting reaction they undergo is what is called the displacement reaction, whereby a more reactive halogen can displace a less reactive halogen from an allyl solution of a less reactive halogen or from the solution of their salt. A typical example, when you have chlorine reacting with sodium bromide, chlorine is more reactive than bromine, so chlorine would displace bromine from the solution of a salt, and you see that chlorine has replaced bromine in that NaBr. Okay, so and this is the ionic equation of uh, of uh, the ionic equation of the reaction. Okay, chlorine moves from 0 to -1, while bromine moves from -1 to 0. Also note that the halogens can dissolve well in cyclohexanes. They are relatively insoluble in polar solvent, but soluble in organic solvent or non-polar solvent. And one of them is cyclohexane. They dissolve well in cyclohexane. So we can look at their ionic equation here, our ionic reaction. Like we have said that uh, um, the higher or the more reactive halogen displaces the less reactive halogen. You could see here again when you have chlorine and potassium iodide. Um, um, when chlorine becomes potassium chloride, for instance, there is a reduction. But when um, Ki becomes I, there is oxidation. Uh, Oxidation is loss of electron, while reduction is gain of electron. For instance, chlorine is moving from 0 to -1. That's reduction, gain of electron. While iodine is moving from -1 to 0. That is loss of electron. That's oxidation. And this is the oxidation half equation, minus 1 um, to 0 by losing 2 electrons. And then for the reduction half equation from 0 to minus 2 here by gaining 2 electrons. So that is the redox equation of that reaction. Okay, so let's look at further reaction. They can also react with hydrogen to form halides, and then when they react with hydrogen to form hydrogen halides, for instance, this is what we have. You have hydrogen fluoride gas, hydrogen chloride gas, hydrogen bromide gas, and hydrogen iodide gas, and this is the description of that reaction. The reaction between hydrogen and fluorine reacts explosively in a cool dark condition. With chlorine reacts explosively in sunlight. Bromine reacts slowly on heating, while iodine forms on an equilibrium mixture on heating. Please study the reaction of hydrogen with halogens very well, and we should be able to describe this reaction. Okay, a quick reasons why we have the reaction in the previous slide that we have mentioned. If you look at the bond energy of this reaction between HF, HCl, HBr, and HI, you will see that the bond energy is decreasing. So that means that fluorine is the most thermally stable, while the hydrogen iodide is the least thermally stable there. So let's look at the uses of halogen. Chlorine is the most abundant halogen and the most important one. Of course, it is gotten from seawater, and it's gotten from seawater. Is specifically used to disinfect water in the municipal treatment of water, and it's also used as bleach. Is why it has a very good oxidizing property, so it can be used as bleach, and that's why you have some of them in substances called hypochloric acid, which is a bleach. You have bromine. Bromine is the only non-metal that is liquid. Take note of that. The only metal that is liquid is mercury, while bromine is the only non-metal that is a liquid extracted from seawater. It is usually used in dyes, as dyes in cosmetics, because of this reddish brown or brown color. Iodine has a shining purple gray and is obtained from seawater. It can be used in dyes because it sublimes. It can be used in um, it can be used in diets to supply to produce dioxin and prevent goiters. Acetylene is radioactive and rare. No known use. So a key assignment here: find out some of the uses of fluorine and put it down uh, in the assignment section or activity section, as the case may be. Okay, let's look at some questions for this class. WAEC 2016 says number 3B1 and 3B2. You have to list 3 characteristics of the halogens, and you have to write a balanced chemical equation to illustrate the reaction between dilute NaOH and fluorine, with the reaction between dilute NaOH with fluorine and then with chlorine. Can you make an attempt to answer this question? Please try make an attempt to answer this question. Okay, let's look at the answer. Some of the characteristics of the halogens. Number 1, like we have said, they are diatomic. Number 2, they are highly electronegative. Number 3, they form ionic compounds with highly electropositive elements or metals, and they form covalent compounds with non-metals. We have said that they are highly reactive and are very good oxidizing agents. We have also said that they are all non-metals and colored. They are all non-metals and colored. So the question says you just write 3. So you can pick any 3 from there. if you are writing that question. Then number 2, you have the question the reaction between chlorine and sodium hydroxide. It will give us NaCl, sodium oxochlorate 1, and then of course water. That is what it will give us. Well, when we add fluorine and NaOH, you are going to have um, sodium fluoride, oxygen difluoride, and water. Now, please take note, in the second reaction here, especially between fluorine and sodium hydroxide, this proportion takes place between fluorine and cold dilute um, sodium hydroxide. So fluorine is reduced to sodium fluoride, and then as well as it is oxidized to oxygen difluoride. That is what is called disproportion reaction. It's a reaction in which a particular substance is reduced and oxidized almost simultaneously. So disproportion is a type of redox reaction where you have reduction and oxidation taking place at the same time. So that's what's called a disproportion reaction. So a disproportion reaction is occurs when fluorine reacts with cold dilute sodium hydroxide. Please take note of that. Let's look at another question. This is why 2007 question 5. It's an objective question. The question says, which of the following properties is characteristics of the halogens? The answer here is ability to accept electrons readily. They are highly electronegative. So they now the D, some students might be asking, why are we not having formation of color compounds? Only transition metal form color compounds. The halogens themselves are colored, but they do not form colored compounds. It is only transition elements that form color compounds. So halogens are colored, not that they form color compounds. The best answer here is that they have the ability to accept electrons readily because they are highly electronegative. Okay, let's look at another YGC question 2017. Halogens react with metals to form salts because they are formed salt formers, like we have said. They form salt. D is the correct answer here. The last question here, the second to the last question here, another question 2019 question 9. Which of the following halogens is liquid at room temperature? Of course, you should know that. The answer is C rather, bromine. Bromine is the only liquid there, a reddish brown liquid. So finally, let's look at WAEC May June 2013. The question says, what is the common name given to group 7 elements? You have to name the hydrides of the first 2 elements in group 7, and you have to state 3 chemical properties of group 7. I want you to answer this question. Try and answer this question. Okay. So let's have the answer. The answer, the common names of group 7 elements they are called halogens. Group 7 elements of the periodic table are called halogens. And then the hydrides of the, like we have said, when hydrogen reacts with the halogens, they form hydrogen halides. So they are also called hydrides of group 7 elements. Now, when hydrogen reacts with fluorine to form hydrogen fluoride, when it reacts with chlorine to form hydrogen chloride, HF and HCl. If you write the chemical formula, you will still be given HF, HCl. Then number 3 question there is the 3 chemical properties of group 7 elements are they have high electron affinity, strong oxidation because they are good oxidizing agents or electron acceptor. They are highly electronegative. They react with hydrogen to form acid. They form salt with metals. They react with alkalis to also form salt. They react with water to form acid. And then there is the lower halogens are displaced from their acid or salts. And then they react with hydrocarbons to form alkyl halides. These are chemical properties. We did not mention those one very well, so you have them here, about 8 chemical properties. We have mentioned others in some of the during the class. You can add these ones to it, and this is the question for the class. So so far so good. We have been able to learn more about halogens. I want you to take some of your past questions and study more about halogens and answer more questions. Continue to learn chemistry, and bye bye. See you in the next video.